The main point on our methane measurements for a global basis is that the amount of methane in the atmosphere is no longer increasing as it was in the 1980s, but rather has been essentially constant for the last 7 years. Methane is this, over the period of time of the last couple of centuries, is the second most important greenhouse gas in the world. And it was determined that it was actually rising by experiments that we did in the late 1970s, finding that the methane, there was more methane in the atmosphere in 1981 than there had been in 1978, and we've been following it ever since. What the greenhouse gases do is intercept terrestrial radiation being given off in the what's called the far infrared, that is invisible radiation of low energy. And the characteristic of some gases is that they intercept that radiation, and that means, because that radiation doesn't escape, that the Earth has to rise in temperature enough to make up for the missing radiation that was intercepted. Carbon dioxide, the number one gas, methane number two, and there are several others. The question on global warming eventually is a summation of the influence of all of these gases that are preventing the escape of this far infrared radiation. And as far as that's concerned, trying to combat global warming means trying to hold down the increases, and in some cases maybe even reverse, such that the concentrations are going down rather than up. There are a number of sources that contribute to methane entering the atmosphere. Cattle emit methane, rice paddies give it off when they're flooded, and then there are leakage from oil and gas. There are associated with coal mines and so on. And the problem with trying to understand any change in methane is that there are so many different sources that are all contributing that it's you have to look for extra information to tell you which source is involved. We have a number of theories, and the problem is how to distinguish among them. Some of the increase in the late 1997 and 1998, we're quite sure accompanied what's called biomass burning, the clearing of forests or agricultural waste just by burning it off. And methane is a prominent product of that. And our experiments indicate that some of the methane increases which were being seen in this time period were caused by biomass burning. At the same time, there are a lot of leaks where connected with oil and gas where methane escapes to the atmosphere. And in the time period of the last few years, some of the places that have had these leaks, notably some of the oil companies, have been trying to close those down, and they may very well have contributed to the changes or the lack of change on the average over the last few years. Our way of collecting methane is to take 2-liter stainless steel canisters, about that size, take them to a distant location. They are equipped with a valve and have been evacuated in the laboratory, and by opening the valve you fill it, you close the valve, and that gives you a sample of the air that was in that particular location. Then we bring them back and analyze them in this laboratory. The technique is known as gas chromatography, which separates one set of molecules with those from another compound, for instance, methane and ethane. And one can then, after you've separated them, you measure the amount that you have, and that's the process that we use for analysis of all these samples. We can do 100 to 200 different compounds depending on where these samples have been obtained. Our first samples of methane were collected in January and February of 1978. At that time, we were just beginning to do this kind of analysis. And over the period of the next few years, we began to do it on a regular basis. Every March, June, September, and December, members of the research group go all over the Pacific and bring back canisters, and about roughly 75 or 80 canisters each of those collection periods. I would hope that we would learn from this that this is a compound which can be controlled, that if we really make an effort, we may be able to reduce it substantially. The measurements of the measurements of old air only go back 20 or 30 years, where you actually took a sample of air and preserved it. But if you look at ice cores, about 10% of the ice in a glacier represents bubbles of air, and those bubbles of air do go back in time. And so we know that 200 years ago, the amount of methane in the air was around 700 parts per billion, and now it's 1,700. So it is possible to think about heading back toward the 700 that existed before we had all of the uses of methane that we have at the present time.